Okay. Power of a quotient. So we talked about briefly yesterday. We went back over the product and the power rule, because those are your two most basic rules. The way to identify one from the other or distinguish one from the other is the parentheses, right? So when they don't have parentheses and you're multiplying two separate bases, you add the exponent. So we get x to the fifth on the first one. Because of the parentheses, that tells us that we need to distribute that outside exponent. And 3 times 2 gives us 6. Now, power of a quotient is going to be a mixture of that power rule, the parentheses, and the quotient rule that we learned yesterday. Okay? So it says if the entire fraction is being raised to a power, then you must distribute the power. Distribute the exponent. By raising the coefficients to the power and multiplying the exponents. With the power rule. Then you can simplify by grouping your coefficients and your bases, your numbers and your letters. Separately with the power and product rule if necessary. Finally, simplify the fraction with the quotient rule. Ready? Okay. Number 1. So the easiest way to tackle these problems when you have parentheses around the whole fraction, that tells you that you must distribute that outside exponent to both the numerator and the denominator. Okay? So you need to assign an exponent to each number or each variable. 3 does not have an exponent, so I'm going to put an exponent of 1. 7 does not have an exponent, so I'm going to put an exponent of 1. We're going to rewrite the whole fraction by first distributing or multiplying that 2 times every exponent. So for the 3, we end up with 3 to the power of what? 2.
Oh.
1 times 2 is 2.
I thought you were talking about the x.
Mm-hmm. X is going to end up being x to the power of 6. 3 times 2 is 6. 7 is going to end up being 7 to the power of 2 squared. Okay? Once you get rid of the parentheses, now you can separate and you can group all of your coefficients and your variables. So one of my coefficients group is going to be 3 squared over 7 squared. So go ahead and put that into your calculator exactly the way you see it there. 3 squared over 7 squared. And the calculator will simplify it for you. What do you get? What's the result?
9 over 49.
9 over 49. Even though both of those have a 9, that is the fraction in its simplest form. It won't get any smaller. Okay? Then your x's, you're just left with x to the 6. That's the only x, so nothing really you can do with that. So your answer is 9 over 49, x to the power of 6. There's only one x. There's no other x, so there's really nothing else you do with that. It just stays the same. Questions? All right. Number 2. The parentheses is around the whole fraction, so you must distribute that outside exponent to every exponent inside, both in the numerator and denominator. So 2 is to the power of 1, 3 to the power of 1, a to the power of 1. First, rewrite your fraction, then worry about grouping. At the top, we end up with 2 to the power of 2 cubed. A to the power of 6b to the power of 12. In the denominator, we end up with 3 to the power of cubed, a cubed, and b to the power of 6. Okay? Once you're done distributing this outside exponent, that gets rid of the parentheses, so now you can do your groups. The first group is 2 cubed over 3 cubed. Put that into your calculator. Use the caret key, the key that's above the division symbol.
I put 3 over.
Yeah, you get 8 over 27. You're going too slow. Then we go into our A's. When you divide the letter, what do you do with the exponent? Subtract. So we get a to the power of 6 minus 3. And 6 minus 3 is? 3. Minus, not divide. Minus. Even though you're dividing the letters, the exponents get subtracted. Okay? B's. The B's are getting divided, but you subtract the exponents. 12 minus 6 is? Yeah, so b to the power of 6. Bring everything back together for your final answer. A cubed, b to the 6th. Okay? Now, there's something a little bit just slightly different with number 3. What's the difference between number 3 and the way number 1 and 2 are? Correct. So the parentheses in numbers 1 and 2 are around the whole fraction, so you have to distribute the outside exponent to both the numerator and the denominator. If you look at number 3, the parentheses is only over the numerator, so you can only distribute that 3 to the top part. Okay? So 36 x to the power of 4 stays exactly the same for the first step. Okay? All right, 3 needs to be to put a 1 on that 3. And at the top, we end up with 3 what? Cubed. And then we end up with x to the power of 6. Okay? Now create your groups. 3 to the power 3 over 36. First group is right here.
27 over 36.
What?
I got 27 over 26.
Simplify it.
Oh, my bad. 1 over 9.
Got 3 over 4.
Should be 3/4. Should be 3/4.
But I need to
So then
get email addresses from Esme and Kaylee for you, Amy. Is that okay?
Oh, yeah. Go for it. Okay. All right. Now our x's, when you divide the variable, you subtract the exponent. So 6 minus 4 is 2. Okay.
So they both have.
Light work.
Not both of them have a different exponent. Both of them.
We good on this one?
Yes, ma'am.
Okay. So, yes, Jesus has already noticed on number 4, the numerator has a different exponent on the outside than the denominator. So, you're going to distribute 2 different numbers. Let's start with the top one. Okay, we're going to distribute that 4. Make sure you assign an exponent to anything that doesn't already have one. So, we're going to end up with 2 to the power of 4. X to the power of 4. And then y to the power of 20.
Whoa.
Now, the denominator has its own exponent of 2. So at the bottom, we'll end up with 2 to the power of x to the power of, and then y to the power of 6. Good. Now we separate and group. 2 to the power of 4 over 2 squared. Yep, it simplifies and it gives you 4. Very good. The second group is your x's. When you divide the letter, when you divide the variable, subtract the exponent. So 4 minus 2 is 2. Okay. And the third group are my y's. Divide the variable, but you subtract the exponent. So 20 minus 6 is 14. Questions?
No.
Joanne? You're good? No? Okay. All right. Number 5. Number 5 is actually a combination of the product rule. There's actually no power rule on this one. It's the product rule at the top. Why? Because neither group of parentheses has an exponent on the outside. Okay? So we actually go straight into grouping.
So what's the point of the
It's just extra practice.
no, like what's the point of the parentheses?
Because you're multiplying one expression times the other expression.
Oh, okay.
I don't know.
All right, so let's start with the first group. The first group is going to be what?
The numbers.
My numbers. So 9 at the top, 9 times 4
What?
over 4. 9, 4, and 4. At the top, we have the 9, the 4, and at the bottom, we have the 4.
Oh, okay, I see now.
9 times 4. I deleted it by accident.
9 times 4 is 36. 36 divided by 4 is?
9.
9.
I need to type it in.
Or cancel the 4s out.
You sweat.
9.
Yeah.
I got the group.
Okay? Yes.
Right.
Because this one's actually still going to be 2 steps. This is a combination of the product rule with the quotient rule. Okay?
Okay, cool. I still don't understand it.
So now we go with the
8.
a's. Okay? At the top, we have a to the power of 7 and a. At the bottom, a cubed. Yes?
Yeah.
Okay? So the second a does not have an exponent. We assign a. And this is an example of the product rule. What do you do with those exponents?
You add them.
You add the 7 and the 1. So you take care of that part first. 7 plus 1 is 8. Now you have that single fraction. When you divide the a's, you do what with the exponents here?
Subtract.
Subtract. So 8 minus 3 is
5.
5.
Oh, what the?
What the what?
I forgot about that.
Mm-hmm.
Technically, this answer is 3.
All right. And then the last group are going to be my group of b's. Okay? The numerator has b squared, b, and then b squared at the bottom. The second b in the numerator needs a 1, and that is an example of the product rule. So what do we need to do with those two exponents? First, we add them. When we add them, we get b cubed over b squared. And now that it is in a single fraction, we subtract the exponents. 3 minus 2, and 3 minus 2 is 1.
So you know when you did like 9 times 4 over 4 and then you just cancel out the 4s, could you have done that? Like, can you always do it if like it's say like A3 at the bottom and then at the top next A3 like A2? Can you cancel it out and it'll still be?
If this were a 3, hold on. If this one were a 3, then yeah, I could have canceled it out.
So you can always do it if there's the
Same exponent.
one. Okay.
Yep. All right. 9a to the 5th, b1. But the only reason that I could do that is because they're multiplied. Like if this were a plus sign here, a to the 7th plus a1, you couldn't do that.
Oh.
Yeah. But you won't see that. So
Question.
what's your question?
I'm confused.
He lost it. Okay, number 6. You do have this one's a combination of the product rule with the power rule and the quotient rule. So this is pretty much as hard as it's going to get. Okay?
Okay, cool.
Here we go. So the first thing we want to do is we want to rewrite our fraction. Then we group, okay? We take care of our outside exponents first. So we're going to rewrite the fraction. The bottom part stays exactly the same. There's no parentheses in the denominator. Okay? Any number that does not have an exponent, assign an exponent. So in the numerator, we're going to end up with what? 2
2 to the squared.
squared, m to the power of
6.
6. Once you distribute that exponent, the parentheses go away. Okay? Now we keep going. 3 to the power of,
3 cubed.
yeah, 3 cubed, and then n to the power of 12. Okay? We got rid of the exponents. First we multiplied. Now we group. Okay? So let's group that. I'm going to make a group for my coefficients for my numbers. At the top in the numerator, we have 2 squared and 3 cubed
It's 4
over 12.
4 times 27 divided by 12.
Not 27.
It is.
Yes.
3 times
Yes. Yes. Sorry. What do you get?
9.
9.
And you add the m.
All right. Now we go with the m's.
But
We have m6 over m5 because they are divided. What do you do with the exponent?
Divide.
And 6 minus 5 is
1.
1. And lastly, we have our n's. We have n12 over n to the 4th. So you subtract the exponents.
N to the 8th.
N to the 8th, correct. So your final answer is 9
9
m n to the 8th.
There's no backside? Great.
No backside,
Do we
yes.
have an assignment today?
Of course.
Why?